In this tutorial, I will demonstrate how to construct a frequency distribution in Excel using the Excel function COUNTIF. What I have here are data from my hypothetical 17 students, the student names reported in column A, and their sex in column B. And what we're going to do is construct a frequency distribution that reports the distribution in terms of sex for these students. So let me first of all begin to construct my frequency distribution. I'll indicate then the variable name. The first bin will be for males, the second bin will count females, and we also will have a total value. And then what we will have over here in the next column to the right, the frequency output that we'll have. Now, the command that we'll use is called a COUNTIF, the COUNTIF function, and we'll, as we do with any formula, begin by typing in the equal sign, and I'll type in COUNTIF, open parenthesis or left parenthesis. Now you notice here what we'll do is identify the range, and by the range what this refers to is the range in which the data are contained, which I will go ahead and highlight that range, B2 through B18, and then comma, and after the comma now we need to specify what the criterion will be. In this case, since our data, the variable sex, is entered as character information, I'm going to need to then indicate what we will count as a male for the criterion and place it in between two double quotation marks. So double quotation mark, and I'm going to type in male, since that's the response that will count someone towards the bin of male, close my double quote, and now close the parenthesis. Hit enter, and what it's done is counted the number of males that are in this class. And if we went through and did a physical count, you would see, a manual count, you would see that there are 7 males here. Now the next thing that I'm going to do is copy and drag then this formula down to the frequency for females. And if we go ahead and double click on this cell, what you'll see here, the formula, I have to change the criterion to female. Currently it's male, but also what we notice here is that the data range that's selected is B3 through B19. Well, that's not the case, but because I copied that formula from cell F5 down into cell F6, it incremented then the data range that I've entered. So let me go ahead and exit that and erase then what we have, delete what's in that cell. And I'm going to come back up here, click on your cell, and what you'll notice then is the formula that was entered in the cell now appears in the formula bar. What I'm going to do is insert then dollar signs before the 2 and dollar sign before the 8, and what that will do then is now turn that from a relative reference into a fixed reference. So no matter how far down I copy this formula, it will always go back and recognize the data range is in the cells B2 through B18. I'll hit enter. Now let's copy this formula down into the next cell. And if we double click here, you'll notice that it's still using the exact same data range, which is what I want. But the problem here is the criterion is still male. We need to change that to female. And hit enter. And now we see that there are 10 females in this class, and if we did a manual count, we would find there'd be a count of 10. I'm going to also then use the sum function to total up our values to get a sense of what's the total number of students in the sample, and there are 17. And one of the things that I want to point out now in terms of the COUNTIF function, if we go back up and click either in cell F5 or F6 so we can see then the formula up in the formula bar, you notice I have male typed in as all lowercase. Now I could just as easily typed in male with an uppercase for the first letter, and you notice the result is the same. I could have instead typed in male, all uppercase, the result is still the same. Or what I could have done instead is have the lowercase m for the first letter and ALE, all caps after that. And what I'm demonstrating here then is that the COUNTIF function is not sensitive to the case in which the character variable is entered into your spreadsheet. So even though sex here is recorded in column B with a capital first letter and lowercase letters after that, it doesn't matter how I enter that information, those labels, into the COUNTIF function. So it's fairly flexible in that respect. So now what we now have is male. Let me go back and I want to make that, just keep it all consistent, all lowercase, just because that's what I like to do. And right there we have our frequency distribution. Now the next thing we can do then, if we want to go beyond this, is compute a percent distribution. So I'll put percent above the top of the third column we have here. And what we'll have will be equal 7 divided by the total of 17 and multiply that by 100. And there are 41.2% of the sample here, or this class, are males. Let's copy that down to the cell below, and you notice now we get an error, pound div divided 0 exclamation mark. What this is telling me is that the formula is trying to divide by 0, and of course that's undefined. We can't perform a mathematical operation where we're dividing one number by 0. If we double click here and notice then the formula, again, as I copied from cell G5 down into cell G6, both the F5 and F7 incremented by 1 because we copied that formula one cell below. But what we see here, which is what we wanted for the number of females, that count should be F6 for computing this percent. But we should have the exact same total cell. So let me go ahead and delete then that formula, go back up here to my original formula here, and what I want to do is make a fixed reference for the total value. So put a $sign in front of the 7 in F7. Doesn't change my result for computing percent of the sample that are males. But now if we go down, compute the percent of the sample that are females, we get a value, and also we notice, yes, that is indeed dividing the frequency of females by the total frequency for this group. The next thing I'll do is again create a sum column, or sum value rather, by summing the column up to that point, 100. What I also will do is I like when I report percents to have them one decimal point or one space to the right of what the data are, and since the data are to the units, I'm going to have one decimal point, so to the 10th. And let's also dress this up. I'm going to highlight then the column labels so they stand apart from the other information that's entered in the cell. And let me also then center everything that we see here. Now the only other thing I need to do here, let's increase the frequency column width, since frequency was kind of, that word was in tight there. And what I also want to do is I tend to separate the total values from the cell information, the information for each category, with a line. So in that case, I highlighted the two total values in F7 and G7. Right mouse button to open up options, click on Format Cells, and now we're brought to the window that allows us to modify how information in these cells is reported. I'm going to click on Border, and right now the default is a thin solid line. I'll make it a little thicker, and also I'll put the border just at the very top, and we can see here then it displays previews as to how the cells are going to look. It's going to have a border at the top, but not along the sides nor on the bottom, which is what I want. And right there, that's how we generate then a frequency distribution for a character variable in Excel using the COUNTIF function. Now for the second example in this tutorial, I will demonstrate how to construct a frequency distribution in Excel using the COUNTIF function, this time with numeric data in our variable. What we have here again is data for my 17 hypothetical students, their name in column A, and then their age in years in column B. And let's create a frequency distribution for the variable age. Now the first thing I want to do is I want to know what are the minimum and maximum values for age in this group. So I'll put in the label min equals and then max equals. In terms of the function, very easily equal min, it's the minimum function, left parenthesis, highlight the data range, close parentheses, hit return, and we see that the minimum value in this data range from B2 through B18 is 23 years. Now let's find the maximum. And just as min was the function for minimum, max is going to be the function for finding the maximum value. Open parenthesis, highlight the data range, close parenthesis, and hit return. And what we see, the data ranges from age of 23 up to an age of 40. So now let's go ahead and start to construct then our frequency distribution. I'll put the variable name age, and then next to that will be frequency. And now let's start to identify then the bins that we have. 23 would be the first category, 24 is the fourth. Now if we highlight both of those values and move your cursor to the lower left hand corner of what is highlighted, you notice the cursor becomes a thin plus sign. Click and drag and this will be an automatic fill. Continues then the series started by 23 to 24, and I'll just grab that all the way down to a value of 40. So that's how we complete the series. It's incremented by 1 from 23 to 24, and it just continues that series through the rest of these values. At the bottom of that column, I'll then generate a total value. So let's put the label total. And now let's construct our frequency distribution. What I'm going to do now is put in equal. The function is the COUNTIF function. Open parenthesis. Identify the range of the data, comma, and now let's type in the criterion that we're using. Cases will fall into this cell if it's equal to 23. Now you notice since we're inputting here now information that is numeric and our variable is numeric, we don't need to include the criterion between double quotation marks. Hit enter. Now what I can do here is I can then copy that formula down if I so choose, but recall when I do that, notice it incremented then the data range. So let's go back up and let's change that data range from a relative reference to a fixed reference by putting dollar signs in front of the 2 and also in front of the 18. Now if I copy that down, you notice what will happen. It does stay at B2 to B18 for the data range, but we still have our criterion of 23. So I'd have to go in here and change that to 24. Well, if we copy it down, one more cell, you notice it's going to be the same formula. I've got to go back in. It keeps the data range the same cells because we have created them as a fixed reference with the dollar signs, but now I've got to change the criterion to 25. And that can be rather tedious to do that for all of these cells that I've got here. Let's go ahead and delete those 2 cells, the formulas in them, and go back up to my first cell where formula is. Instead of the actual value, 23 years, let's put in the cell reference. The value of 23 is in cell E5. Hit enter. Now what you'll see, I don't need to put the cell reference in between double quotation marks because it's referring to a numeric value that's in cell E5. And now let's go ahead and copy this all the way down through the entire range of data. What you'll notice here then, as we copied it down, the cell reference changes with each row we copy it down. So we go and look at, for example, what's in cell F13. Whoops. And you notice here the data range stays the same, B2 to B18, because it's been entered in as a fixed references with those dollar signs in front of each of the numbers. But the criterion has changed, and what we see here now is we want to count the number of cases that have a value of 31 in our data range, which is exactly what we want. So using that as a relative reference, what I can do now is very easily just enter that formula in once, copy it down, and what we end up then is with our frequency distribution. Let me go ahead and finish our frequency distribution by computing here then a total value. Let me also then add border above that total cell, and I did this very quickly, highlight that cell, right mouse button, click, select Format Cells. If it came up border, because I recently used the border option, if instead it comes up with number or some other tab selected, just click on border to open that up. It shows a box here around the thin line, which means that's the default. It's going to put a solid thin line here for the border. I'm going to make it a little thicker, and here we choose where around the cell it's going to be. I just want it on the top, and here it displays a preview. Hit enter, and that's exactly what I want. Now I can, if I so choose, dress this up a little bit by bolding the headings of those columns to make them stand out from the data themselves. Let's select all of the information here, and let's make it in that case, center, and that's our frequency distribution. Now you notice one of the problems we see here with this particular frequency distribution is that there are very few cells that have more than one or two cases, well, that have three cases or at all, and quite a few cells that have 0 or 1 case. This is not a terribly useful frequency distribution to report because the data are so widely spread, since we have so many empty cells and cells with just one case entered in. This would be a situation where what I would want to do is to report age as a group frequency distribution, collapsing some of these ages together, which is what we'll do in example number 3 for this tutorial. Now for this third example, we're going to use the same data we used in example 2, that is student age, and you notice that we've already determined the minimum and maximum values. But what we're going to do this time is construct a grouped frequency distribution, combine many of those categories together. So let's first of all begin to type in the information to define the frequency distribution, so the variable age and the frequency category. Now I'll type in the bins, the bin labels, and the last one here will be 40 to 44 years of age. Those are my bins that I'm using here, and I'll also add a total column, a value there, bottom of that column. So what we're going to do in the very first cell, equal, and type in the COUNTIF, open parenthesis, again identify the data range when using the same data, so the same range, B2 through B18, comma, and the criterion we're going to use here is double quotation mark, less than, and 25. Now the reason why I chose less than 25 is 25 is the lower limit that we see for the next bin that we're using. Now even though we can put the number 25 as a criterion without using the double quotation marks, because I'm also including then the less than sign before 25, that's a character, that's not numeric, so we'll have to put then that information into double quotation marks. What I will also do here is make my data range fixed reference, because I'm going to copy this down into the cells below one at a time. And there we have it, 6 students fall in the range of 20 to 24 years of age, that first bin. Now let me go ahead and copy this down into the next cell. And what we'll do here now is change the criterion that we use. And in this case, instead of less than 25, I'll have less than whatever the minimum value is for the next bin, and that's a value of 30. Now if I just hit enter at this point, what it's going to do is merely count the number of individuals that have values less than 30, and that's 12. But that includes not only people who are 25 to 29 years of age, but also those who are 20 to 24 years of age. What I want to do, though, is to subtract then those individuals in the lower age bracket from my count here for this cell. What we can do when we are using functions in Excel is we can work with them mathematically. We can add them or subtract them and so on. So I'm going to minus COUNTIF, open parenthesis, and again I'll use the same data range, B $2 to B $18. That's a fixed reference then. Oops, I put 28. That should be 18. Comma. And now what I want to do is identify the cases that don't belong in the second bin, and that is those cases that are ages 20 to 24, or as I specified before, less than 25 years of age. And now we end up then with 6 people in that second category. Let's copy this formula down to the next cell and modify it again. This time I'm going to start counting of individuals who fall below 35 years of age, because that's the lower limit for the fourth category. And now I'm going to subtract all those individuals that fall below this particular category, that is those that are less than 30 years of age. And what we see here now are 3 people that fall in the range 30 to 34. Let's do the same thing now for the next bin. And what we'll have here now will be individuals who are less than 40 years of age. That's the lower limit for the next bin. Subtracting from that all those individuals that fall in the bins below this one, that is, they have ages less than 35 years. And lastly, let's now copy this to the last cell, and what I will do here is just delete then the second COUNTIF statement, and what we will do instead is have anyone who has an age that is greater than 39. So I'll just specify one criterion. In that case, I'm using the upper limit for the previous bin. And one person falls in that category. Let's sum these up, these cell frequencies. I end up with 17 as I should. Let's also construct a percent distribution equal, divide by the cell count for that first bin, or that cell count for the first bin rather, divided by the total times 100, and keep in mind we're going to have the same cell reference for the total value for all of our computations here for this percentage distribution. So I'll enter in a $sign to make that a fixed reference, but the numerator will stay a relative reference, so it's going to increment by 1 with each row that we copy it down. And I will simply then bring that down, copy it to all cells. Again, I will sum this column up, and it should equal roughly 100, which it does. Let me go ahead and change now the decimals down to 1 decimal. I like to have my percents go one place to the left, or right rather, of our data. And since our data are units, I'll go 1 place to the right, and that's going to be to the 10th. And we can also now construct a cumulative percentage distribution. The very first cumulative percent value is going to be what the percentage is in the first bin. Now I will add to that the percent that fall into the second bin. I will add to that then the percent that now fall into the third bin. I will add to that the percent that fall into the fourth bin. And lastly, I will add to that the percent that fall into the last bin. Now, when we have a cumulative percentage distribution, we should see then that the very last cumulative percent for the last bin should equal 100% unless we're off by 1/10 or so due to rounding error, which it does. Let me now go ahead and add bars above my total values for frequency and percent. highlight those cells, right mouse button to bring up my options, click on Format Tabs, open Borders option. Currently it has a thin solid line for the default. I'll make it a little thicker, and then I will put that only the top of the border for those two cells. Hit enter, which is what we have here. Now let me go ahead and I will put my headers into bold so it stands out from the data. I also then will make a couple of these a little bit larger so that the words in each header fit comfortably within them. And let me go ahead and highlight the entire range, and I'm just going to center all these values. And there we have it, a frequency distribution for the grouped age data using the COUNTIF function, and I've added the percent distribution and the cumulative percent distribution.